Hey guys, Mr. Falcucci here. Happy Friday. Just wanted to go over 2011 number 5 with you. You started working on this on the end of class on Wednesday. Just want to make sure you have the worked out solution. So hopefully this helps, let you know if you got it right or wrong and answer any questions that you might have about it. So, okay, we have a computer output here. We're talking about a windmill. All right, so if we're starting out right here, A says use the computer output to determine the equation of the least squares regression line. Identify all variables used in the equation. So first thing we need to look at, okay, what is our response variable? It's right up there, okay? Electricity production is what we are trying to predict. So electricity production is our response variable. Okay, we're going to put a little hat over it so we know that this is a prediction. Okay, and what is that equal to? Our constant. All right, we talked about that being our y-intercept. So our coefficient for our constant right there, okay, 0.137. 137 plus, okay, that right there is our response variable, okay, with the slope that goes with it, plus 0.240 times wind velocity. Okay, and that's literally all you need right there, okay? We've put our words in for our variables right there, so our equation is in context, and we are good to go. If we jump over here to part B, there's two ways that we could tackle part B. So the first way we could tackle it, okay, is how much more electricity would the windmill be expected to produce on the day when the wind velocity is 25 versus 15? We could do this one of two ways, okay? Way number one is we could find, right, we can find the predicted electricity. So we can find the predicted electricity, all right, for when it's 25 miles an hour and when it's 15 miles per hour, and then figure out the difference there. So my formula right here, electricity hat equals 0.137 plus 0.240 times wind velocity. So if I did that first, 0.137 plus 0.240 times 25, right? If I take out my calculator here, I'm just going to do it by hand here, not on the screen, but 0.137 plus 0.240 times 25 gives me a predicted, electricity production of 6.137. Okay? And then I would do the same thing again for when it's 15. So when it's 15 here, right, I would have predicted electricity equals 0.137 plus 0.240 times 15. If I do that out in the calculator, I get, it would help if I didn't put a typo in the calculator. Okay, I get my electricity, my predicted electricity would be 3.737. Now, how much more are we expecting? Just subtract the two right now. So 6.137 minus 3.737. And I get 2.4. Okay, so according to the model, all right, electricity production is predicted, right? We want to make sure we use that word predicted, is predicted to be 2.4 amps higher at 25 miles per hour versus 15 miles per hour. All right. So that would be the first option to do it here. Also, what we could have done, another way right here, we could recognize that, okay, 25 miles per hour is simply 10 miles per hour faster than 15. So we could have just done 10 miles per hour, right, times my slope at 0.240, which would also given us our 2.4 amps. Okay, so either one of those would have been a perfectly acceptable way to reach the correct solution. But notice here, right up here, what we want to make sure we have is I have my answer written up here in context, okay, in relation to the prompt. And then what proportion of the variation in electricity production is explained by the linear relationship with wind and velocity? That is simply an R squared question right here. So if I go back, I can see R squared right here is 0.873. And you're literally just going to use that exact same front sentence frame that I showed you. So 87.3% of the variability in my response variable, which is electricity production, okay, can be accounted for by the variation in wind speed. So 87.3% of the variability in electricity production can be accounted for by the variation in wind speed. So I hope that video was helpful for you guys there to go over parts A, B, and C. If you have any other questions about this, please bring them to class on Monday, or feel free to reach out to me via email. I hope you guys all have a great weekend, and I'll see you in class on Monday.